Okay, so this is going to be an introduction to Module 1, Lesson 4 in our College Prep Math 3 class. This lesson's all about these things called linear inequalities. And in the real world, when we're dealing with math, many solutions don't have just a single answer, right? An example of this would be if you're an Olympic sprinter, you're trying to qualify to get into a meet, and you need to run a time of less than 10 seconds to qualify for that meet, right? Well, there's a lot of times they're going to meet that criteria, 9.8, 9.7, 9.5. There's an infinite number of times that will satisfy that criteria. And so we use inequalities to represent these types of situations. So x is less than 10 is how you read this statement that I just boxed here. And it's exactly what we were just talking about. We need to run a time of less than 10 seconds. Well, this symbol here tells us that we want to have a time of less than 10. Okay. And we do want to pay attention to the fact that 10 doesn't satisfy this particular inequality statement because 10 is not less than 10, right? If I just change it slightly though, if I write a separate inequality over here that looks like this, x is less than or equal to 10, now similar, because all those times that are less than 10 are still going to satisfy this statement, but 10 does solve this statement and not the first one. So I want to pay attention to those equal signs. Makes a big difference as far as our endpoints go there and what's going to happen. Now, the solutions to these kinds of inequalities can be presented a few different ways. These that I've boxed are the inequality statements. You'll have to give some of those in this homework, but you'll also be asked to give graphs that represent the solution sets to these inequalities as well. And it's not just a single point on the graph, right? Because really anything that's less than 10 is going to solve this particular inequality. And so what I'm going to do is I'm going to shade part of a number line to represent the solution set to these things. So I'm going to find 10 on my number line. I want the things that are less than 10. So values like 9, 8, 7, even all the way down to 0 would satisfy this. So I'm going to shade that side of my number line to represent the solution set. And, values that are less than 10, they're going to keep going to the left forever, right? And then what I need to do next is I need to make sure I'm thinking about what is going to happen at that end point. So for this inequality right here, okay, 10 is not part of my solution set. I need to make sure I'm indicating that on my graph, okay? If I want to indicate that, we're going right up to 10, but we're not going to include 10, I'm going to use a parenthesis there. A parenthesis on our graph indicates that we approach that, but we don't include that endpoint. And that is appropriate for this first inequality statement over here because 10 is not less than 10. We don't want to include 10 in our interval. So we're going to use a parenthesis there to indicate that. If I'd been doing a graph for the other one, just a quick graph for this one over here. Again, you notice I'm not going to take a lot of time to show every single point on this graph. You don't have to. What you want to do is you want to find your key point, which is at 10, and then you want to shade the appropriate side of the number line. In this case, I'm going to be shading the left side of my number line, because those are the values that are less than 10. Okay, and then I'm going to think about what happens at that endpoint. In this case, less than or equal to means we want to include that endpoint. When I want to include a value, I'm going to use a square bracket instead. Okay, and so slight difference, but it does make a big difference, especially if you're that Olympic sprinter. You're running time of exactly 10 seconds. In the first case, you don't make the Olympic team. In the second case, you do because of that less than or equal to there. So, but you do want to really be thinking about what's happening at your endpoints. Sometimes we'll include them and sometimes we won't. Okay, so the last way that we're going to report the solutions whenever we're asked to tell what the solution set is for a linear inequality like this is with this thing called an interval. And I always like to start with my graph and use my graph to get my interval. So if I'm looking at this graph right here, I want to write an interval that represents this set. What I'm going to do is I'm going to work my way across this graph from left to right. And I want to start by trying to locate my leftmost point. In this case, this graph goes to the left forever. It just keeps going, right? And so whenever we have a situation like this where our graph goes to the left forever, we're going to say that our interval starts at negative infinity. Infinity is a symbol in math that we use to say that something just keeps going. In this case, it keeps going to the left, which their values are negative over there. So we say that the interval for this thing starts at negative infinity, and then we're going to work our way across the graph from left to right until we get to our right endpoint. Well, this thing ends at 10. So 10 is going to be our end of our interval. The last thing that I need to do to finish an interval like this is I need to think about my endpoints and whether I include them or not. Now, infinities and negative infinities, those are not values. They're never going to be included in our solutions. And so we're always going to use parentheses to represent that, just like we did in our graph. We didn't want to include this 10 up here, so we used a parenthesis to indicate that it's not really part of our graph. Here, infinities, negative infinities, not really values that we can include, so we want parentheses there as well. Now, the 10 on the other side, we need to think about that one a little more because sometimes we'll include it and sometimes we won't. In this particular problem, we will not include it. It's a parenthesis up here. We want a parenthesis in our interval as well. Okay, let's do an interval for this other graph instead. Same process. We're going to work our way across our number line from left to right. And again, we're going to go to the left forever. So we're going to start our interval at negative infinity. And then we're going to work our way across until we get to 10. Negative infinities, positive infinities, these are not values that we can include, so they're always going to get parentheses. But in this one, the 10 is really part of our graph. 10 is less than or equal to 10, part of our solution set. So we're going to include that by using a square bracket over there on our interval. Okay. Now, I know this bothers some English majors when we have a parenthesis that we open and then we don't close, but it's just kind of the way it works in math. They don't have to match up. Our intervals are symbols here are telling us a little bit about what happens at those endpoints, and so they don't have to match. Okay, sometimes when we're dealing with linear inequalities, we'll have a situation like this. This is what's called a compound inequality. We would read this: -2 is less than x is less than 3. And typically what I think when I see a compound inequality is that x is trapped between our two values that are on the outside. So x is between -2 and 3 is going to be where our solution set for this particular compound inequality is. In general, I'm going to solve this a couple of different ways. This particular question says to take the inequality and graph it and then give the solution set as an interval. So we're going to answer kind of the same questions that we did on the last problem. If I want to graph this, it's actually pretty easy. I'm just going to graph the part of the number line that's between our two values. I'm going to graph this central part here between the -2 and the 3. Kind of shade that in. And then just like we did in the last problem, we want to really think about what is going to happen at our endpoints, because sometimes we'll include them and sometimes we won't. -2, notice there's no equal sign on this inequality symbol, right? So we don't want to include that. So we're going to use a parenthesis over there because it's not part of our solution. Same thing over here for the 3. 3, there's no equal sign on our inequality symbol. So again, we're not going to include that endpoint there. Okay, so we're going to use a parenthesis on that one as well. So again, this compound inequality says that x is between these two values. We shade the center region there. Okay, and then we really want to think about what's happening at our endpoints here. In this case, both of them are not included because there's no equal signs. So we use parentheses for both of those. If there was a less than or equal to instead, we'd use a square bracket instead when we're doing our graph. Okay, and so now we've got our graph on our number line here for this problem. The last thing that we were asked to do is to find the interval notation for this particular problem. We're going to do that just like we did in the last problem as well. We're going to work our way across our number line from left to right. This one does have a leftmost point though, so we're going to start our interval at -2, and then we're going to work our way across to our rightmost point, which is 3. Okay, then we're going to think about what's happening at those endpoints. We're going to include them if we should. In this case, we're not going to include them because there's parentheses in our graph. So we're going to have parentheses for both of these. Again, there's no equal sign on our inequality symbols, so we don't want to include those endpoints in our interval either. So you're really going to have to get comfortable with writing solutions three ways for these things. You're going to have inequality symbols, which is our first line here. You're going to have graphs on the number line, and then you're going to have intervals, and you need to be comfortable with writing solutions in all three of those ways. So sometimes in our inequality problems, we'll have a little more going on. So this is going to be an example of a problem that we'll need to do some work in order to see what the solution set looks like. Now, the good news is when we're dealing with inequalities, the rules for what we can do are very similar to what we've done in equations earlier in this module, right? We can do a lot of the same calculations and algebra to manipulate these equations. There is one exception, though. There's one kind of special rule that you have to keep in mind when you're working with inequalities, and that is if you ever multiply or divide an inequality by a negative number, you have to flip your inequality sign. So that's kind of the only special rule that we'll run into. And we'll definitely see that in this problem. So we want to keep that in mind. If you ever multiply or divide your inequality by the same negative number, okay, you need to flip your inequality sign. Okay, other than that, we'll be able to use our addition properties of equality and multiplication properties of equality in exactly the same way we're used to. Okay? So let's go through this process. We're going to solve this equation for x to get started, okay? And we're going to use all of the same strategies that we've used in previous lessons in this module, just with that one extra rule we have to keep in mind. So the first thing I'm going to do is I'm going to start to get my like terms together. So maybe I'll move this 6 over, get all my constant values onto the right. And if I do that, maybe I want to move this -6 over as well to get all my x values onto the left. That'll get rid of those terms there, right? 5x minus 6x is -1x. And 2 plus 6 over on the right gives me 8. Okay, so the next step here is going to be to divide by -1. And this is where you really have to be paying attention because you got to have like a little alarm in your head that goes off. If you're ever taking an inequality like this and multiplying or dividing it by a negative number, we have to flip our inequality sign. So I'm going to cancel these -1s just like we've seen before, but I'm also going to flip this greater than or equal to sign and change it into a less than or equal to sign. Okay? And now I've got my x by itself. So just like what we've been doing all module long, we want to get that x by itself. So I'm done with my solution. Do have to make sure I flip that inequality sign if I want to get this right. Okay, so there's our inequality solution to this problem. And like we've seen in some of the last couple of problems, we want to give the solution a few different ways. This is our inequality. Next, we want to give it a graph. And so we're going to do the same kind of process. We're going to look at our graph. Okay, here's 0. Whoops, let's put the 0 over here. And then -8 over here somewhere to the left of 0. And then we want to think about which side of our number line to shade. We want to graph the side that's less than or equal to -8. So things that are less than -8 are things like -9, -10. We want the left side of our number line. This is going to be true anytime our x is over there on the left and by itself. We're going to want to shade the left side if we're doing a less than or equal to equation like this. Okay, and then we want to think about what happens at our endpoint in all these problems as well. At -8, we want to include it, and so we're going to use a square bracket there. Again, the reason why we want to include it is because we have that less than or equal to symbol. Okay, so there's what our graph looks like. Our last step then is to get an interval. And I always like to start with the graph. So I'm going to work from the graph, and I'm going to work my way across the graph from left to right to get my interval together. So if I'm looking for a leftmost point, well, this thing goes to the left forever. So we would start at -infinity. Okay, and then we'll work our way across to our rightmost point, which is at -8. We want to think about what's happening at those intervals. Don't think about infinities too much. You don't have to. Infinities are never included. Infinities, negative infinities will always get parentheses. -8, though, on the other hand, is going to be included. It's part of our solution set. We've got a square bracket in our graph. We have a less than or equal to in our inequality. So we need to include that endpoint. We're going to use a square bracket there for that. Okay, and again, these don't match. That's okay. It's not unusual at all. Okay, so hopefully that's enough to get you off to a decent start with this linear inequality stuff. Please don't hesitate to let me know if you need any more help or if there's any questions that I can answer. Y'all have a good weekend.